Good afternoon. Thank you for taking the time for me to present the following report conducted under the guidelines of Elizabeth Berg on the production operations of performance lawn equipment. This study was analyzed using the data collected by PLE over the last 5 years. Here is a quick overview of the sales patterns for PLE mowers and tractors across the globe. As the majority of sales comes from North America, you will notice that the global sales pattern in purple follows a similar trend to that of North America. This being stated, most of North America and Europe follow seasonal weather patterns, therefore the need for lawnmowers is usually during the spring and summer months. For this reason, as displayed in the visuals, the sales patterns tend to become cyclic. Using regressional trend analysis, we find that the global mower sales has a steady incremental linear growth, whereas global sales tractors have an exponential growth. Although global mower and tractor sales are in growth, this can be misconstrued due to the significant growth in the North American market. If you take a closer look at the graphs, you will notice that sales in both the European Pacific regions are in decline. In order for PLE to maintain a global status in the market, more emphasis would have to be put into diversifying its products to meet global standards. PLE has always maintained between 9 and 10% of the global market share. From 2011 to 2012, there was a dip in the mower sales by 0.4%. The tractor market share has increased by 1.4%. However, this is once again due to the high sales in the North American market. The European Pacific regions have a decrease in market share. Comparing both visuals, you will notice a positive trend for PLE sales compared to that of the industry. Global sales for PLE mowers remained consistent, even though the industry as a whole took a dip between 2008 and 2012. However, the reason for the decrease in the market share was probably due to firms going out of business and their customers going to other competitive firms, thereby concentrating the market. PLE tractor sales has a similar trend line to that of the industry, polynomial to the order 3. Starting the trend line equations, it is noted that PLE trend line is increasing at a faster pace. To get a better understanding of the financial trends, we did a study of the dealer and end-user satisfaction ratings over the last 5 years. As you will notice, at first glance there's a common trend between the two. Overall, the satisfaction reports from both dealers and end-users are positive. The only concerns in these visuals are the increase in 0 ratings for the dealer responses in 2012 and a slight decrease in 5 ratings for end users from 2011 to 2012. These values, however, are once again heavily influenced by the North American market. They also include ratings from newly opened Chinese market. The ratings for this market are a little inconsistent due to the sample sizes, as it has only been in operation just over 3 years. Breaking down the visuals in the previous slide by regions, we get the following results. As you can see, the ratings are still pretty high for all regions, being in the high 4s and 5s. However, in the Europe and Pacific regions, the 4 ratings are more common, whereas in North America, the 5 ratings are most frequent. In order to improve these ratings, we did an analysis on the number of complaints, number of defects after delivery, percentage of on-time delivery, and the response times to customer service calls. Starting the first graph, you will notice a cyclic trend similar to the sales trend. This is once again because lawnmowers and tractors are used on a seasonal basis. What is interesting here is a gradual increase in global complaints, although the number of complaints for the North American market is constant. This shows that the increase in complaints is due to an increase in unsatisfied customers in other parts of the world. The number of defects after delivery has improved significantly. You'll notice that each year this number is decreasing. The percentage of on-time deliveries is pretty constant at around the 99% level. Looking at the graph, you will notice this to be true, with a few outliers at the beginning of 2008 and at the end of 2012. A scatter graph is used to measure the response times to customer service calls by quarter. Majority of the dots are concentrated between 1 and 6 minutes, which is considered an adequate response time. An enhanced estimate to response time with reasonable assurance was calculated. It was found the average response time and the standard deviation to be 3.47 and 1.63 minutes. Using these values and a confidence level of 95%, an error margin of 0.16 minutes was deduced. Therefore, a good estimate response time will be between 3.31 and 3.63 minutes. The overall response for top box responses is quite positive, usually being 80 to 90% of the responses. However, what is concerning is the pricing for the North American and South American markets, having the top box responses in the 60% area. Another major concern is the price and service responses in the Chinese market, having incredibly low top box responses of 20 and 10%. However, the sample size is much lower for this region and can decrease the accuracy of the results. Since the ratings in Europe was a little lower compared to North America, a hypothesis test was done to determine if there was significant difference in service between the two regions. Using a null hypothesis of HO is equal to North America, which is equal to Europe, we found the test statistics in the top box responses. As you will notice, the p-value is obtained and is greater than 0.05. Therefore, we fail to reject this null hypothesis. This states that when it comes to top box responses, the difference in region is not a determining variable. Here is a more detailed analysis on the defects after delivery over the past 5 years. There's a total of 54 failures out of 3,100 observations made, bringing the percentage of failure to 1.7%. In order to determine whether defects after delivery have changed significantly over the past 5 years, we used a null hypothesis test of HO is equal to mu1 minus mu2, which is less than or equal to 0, where mu1 is equal to 2008 and mu2 is equal to 2012. If null hypothesis is rejected, there is significantly lower defects per million items received. This was determined by running a two-sample hypothesis test. As seen in the results table, the p-value is extremely low and the t-stat value is greater than the t-critical value. For this reason, the null hypothesis is rejected and there is significantly lower defects over the years. In order to decrease the number of defects, PLE coordinated with its suppliers and implemented a supply-initiated program in August of 2011. A study was done to determine how significant the supply initiative was on the decrease in defects. The graph depicts a trend in defects up until the initiated program was implemented. As you will notice, there was a slight decrease in the defected parts. Using the equation of this trend line, we derived that at the end of December 2012, the number of defects would have decreased to around 308 units. However, after introducing the supply initiative, the number of defects at the end of 2012 was 436 units. This shows that the number of defects was on a downward trend and the supply initiative might not have been the cause of the lower defects. The following map depicts the sites for current plants and proposed plants. The idea behind international plants in areas where complaints are higher and ratings are lower could be beneficial in increasing customer service and lead times. However, when comparing the mean shipping cost by quartile, you will notice the mean shipping cost for the mowers from its current plants are a lot more cost effective. However, a different trend is obtained for tractor shipping costs, where proposed plants are showing a more cost-effective solution. At the current plants, engineers have collected data on alternative process costs for manufacturing transmissions. In order to determine whether one of the proposed processes is better than the current, the mean for each process with its error margins while using a 95% confidence level was calculated as seen in the table. As you will notice, process A has the lowest average cost out of the three, but also the highest error margin. For this reason, process B will be a more suitable replacement, having more consistent figures and having a low error margin of 7.5 compared to 23.2 and 16.2. In order to calculate the consistency of blade production, a sample of 350 blades were weighed. As you will notice, the blade weight is pretty consistent with one outlier. The mean weight was calculated to be 4.99 pounds with a standard deviation of 0.109 pounds. As discussed in the previous slide, engineers had developed two alternative processes for transmission manufacturing. To determine whether the proposed processes are better than the current, a comparison between two different sample mean tests were done, using mu1 equals current, mu2 equals process A, and mu3 being process B. Two different analyses were undertaken, current process versus process A, and current process versus process B. In the first analysis involving process A, we learned that the t-stat is less than the t-critical value, and the p-value is greater than 0.05. Therefore, we failed to reject the null hypothesis, which establishes that process A is not significantly more cost-effective than the current process. The second analysis displays a similar set of results. This concludes that the alternative processes do not have significantly positive attributes in order to switch from the current process. With the discussion of implementing new manufacturing process and new plants, it is important to understand the learning curve during these changes. To get better awareness of implementing new technology and the effect it has on the workforce, an analysis was undertaken on the manufacturing time of 50 newly designed engines. As seen in the first graph, the sample size is too small and it is challenging to determine when the line is constant. Using the equation of the logarithmic trend line, the production time for the next 100 samples is calculated. Using the predicted times as seen in the second chart, we established that the production times start evening out at around 40 minutes. Cross-referencing this value, we learned that the learning curve for implementing a new technology is around 120 units. Here we have a study on the retention rates of current and past employees. A categorical analysis was done to determine if gender, college degree, or being a local significantly affects the retention rate. The results of these variables being categorical, we had to rely on hypothesis testing. In the first test, we studied the retention rate for males and females using a null hypothesis of HO is equal to male is equal to female. This being a two-tailed test, we are concerned with the values at the very bottom of the table. The t-stat value is less than the t-critical value. Therefore, there is no strong evidence to reject the null hypothesis. This means that gender does not play a significant role in retention rates. The second test uses a similar process in determining whether having a college degree has any effect on the retention rates using the following null hypothesis. HO is equal to yes is equal to no. Once again, we failed to reject the null hypothesis. The t-stat is less than the upper t-critical value. Therefore, having a college degree does not influence the retention rate. The final test in this study was to determine the effects of being local on the retention rate. Using a null hypothesis similar to that of the college degree, a t-test was carried out. Here we see that the t-stat value is much greater than the t-critical value, which means we have strong evidence to reject the null hypothesis. This determines that being local has a strong influence on the retention rates. Finally, we did a similar study to determine the effects that years of education, college grade point average, and the age when hired had on the retention rate. Considering the following values were numerical, we were able to run a regressional analysis for comparison. In the first analysis, we obtained a significance value of 0.11, greater than 95% level of confidence of 0.05. Studying the p-values, we found that the years of education had the highest value of 0.85, well over 0.05, and a t-stat value of 0.18, which is less than 1. This determines that the years of education is not a significant factor, and therefore we reran the analysis without this variable. In the second analysis, the adjusted R-square had increased, which is a good sign, and its significance value had decreased, however, was still slightly above 0.05. The p-value for college GPA of 0.57 was still above 0.05, and the t-stat value of 0.57 was less than 1. This meant that the college GPA as well did not have statistical significance on the retention rate, and analysis had to be run for a third time. In the final analysis results showed that the adjusted R-square had further increased and significance level of 0.016 was below 0.05. The p-value of 0.016 is below 0.05, and the t-stab value of 2.50 is greater than 1. Therefore, out of the three variables, age is the only independent variable that is statistically significant to retention. These variables, such as age and being local, are contributing factors when determining new plant sites and avoiding learning curves on a more frequent basis. In conclusion, PLE sales are positive and are increasing at an exponential rate. However, if it hopes to maintain its position as a competitor in the global market, more resources would have to be distributed outside of North America. When doing so, factors such as shipping costs, retention rates, and learning curves will have to be considered. This concludes my presentation. Please feel free to let me know if you have any further questions. Thank you.